Hi guys, this is gonna be a video on 6.1. I just have to close a couple tabs and get going here. So once we're done with chapter 6, I might have another section from chapter 7, and then that will cover up to test 2. And so you should be working on these now. Basically, you should be working on chapter 4 and 5. There's only one section from chapter 4. There's only 4 from chapter 5. It's all relevant. It's all useful. It's not just some random topics to go over. They're very much the core of Stats 1, any Stats 1 college course. Chapter 6 is hopefully interesting. There's stuff that you're gonna like, there's stuff that you're not gonna like. I think 6.1 is a good section. 6.2, I don't want to speak on it yet, but we'll make that shortly. And then we have a couple cool ones in there. So let's jump in. And there's a lot to learn in this video, so I do hope it helps. There's tons of really good shortcuts. At some point in April, I'm going to start to make videos kind of going back over some of the sections. I'll open all the sections as well if you want to practice them, and it'll show you how to do a lot of the calculations by hand. Some of the stuff is pretty straightforward. You don't need a video, calculating the mean. Standard deviation is not straightforward, so those are things that are going to be on the final that we have to do by hand, but we'll get to that when we get there. Question 1 is just definition of a random variable, so not a big deal. Question 2, again, sort of what's true about probabilities? They have to add to 1, and each probability of an event or of a sample space has to be between 0 and 1 clues. This is talking about discrete and continuous. I have no idea why the book introduces that here. It should have been way in the beginning of the course, and I think it actually was. And they're just sort of reiterating stuff. And you'll see a few topics pop back in. So a light bulb is that discrete or continuous? And it's a really perfect example of what the difference is. Discrete are things that have to be integers. Like you can't have half of a light bulb. You can only have 1, 2, 3, 4, 5, 6, or 0. Things that are continuous are not as obvious. So the number of light bulbs that burn out on the street is discrete, okay? So, what's it doing? Okay. The distance in feet a baseball travels in the air, that's a little more complex. So let's maybe draw, I don't know if we can draw this, but you draw a baseball hit in the air, right? You can never say this is a little like, this is a paradoxical thing. Let's say you hit it 120 feet in the air, right? Is it actually 120 feet? Not really, right? We can't measure down to like atoms and say it's just perfectly 120. So that's going to be more of a continuous thing. And a better example is in, where'd you go? Question 4. A T-bone steak, a weight of a T-bone steak, typically would be in ounces, maybe pounds, right? Think about this. If I said, here you go, sir, your steak that you ordered is 16 ounces, which is a good size, about a pound. It's not actually 16 ounces, is it? There's no way we can perfectly measure it. So that would be continuous, right? Discrete are things that are just have to be an integer number, right? So like part A is definitely discrete. I mean, sorry, discrete, because you can't have a half a person being a certain blood type or whatever. Okay, so those aren't too bad. Now so we're gonna do a ton of Statcrunch stuff here. And there's a really straightforward way to do it. Not with this one. This one's kind of simple. So question 5 you can do. But let's see if question 6 has Statcrunch. Okay, kind of does, but it's still asking us a question. Could this be a discrete probability? Why or why not? I'll let you guys think about that. But um, think about the hint would be, what do all the probabilities have to add to? They have to add to 1. Okay. Um, so I found a really awesome way to do this problem using Statcrunch. So for part for part A, I'll show you how to do. For part B, rather, part A is just asking definition. Part B wants a plot. So go to open the data, go to bar plot with summary. Categories is X, counts is P of X, and hit compute. And it's not a perfect match, but you can see that this is going to match part A. That's how we got this one. Now, please pay attention to this part. So we're going to do this a lot in this section. When we have a probability distribution, meaning we have probabilities associated with certain events or things, right? In this case, it's number of marriages a person has. The way to do it, rather than multiplying by hand, and again, I'll show you how to do this by hand too, but you can do stat, calculators, custom, and then select the values as X and weights as P of X, then hit compute. It does give us the right graph too, but it also gives us the mean. So it gives us the mean, which is 0.963, and it gives us the standard deviation as well, 0.8 right here. You'd have to round it, okay? So that's that. Question 8. Again, I don't have to do this problem, but I know at some point it's going to ask me for the mean, for the standard deviation. So because it's already calculated in probability, I open it up. And the only way to get Statcrunch to calculate this is to do stat, calculators, custom, select values as X, weights as P of X, compute. And you can see it gives me the mean and the standard deviation. So this does about a third of the problem, or maybe half the problem right here, okay? So, the first part is asking you to fill in the blanks, but it's just definition stuff. Question 9. Now you're gonna laugh. You're gonna be like, oh, you got it wrong. No, I didn't. Look, I put 0.222 and it just wanted to go further. So this one's a little tricky. Um, so if you open the data, there's really no way around this one, unfortunately. We'd have to probably do this one by hand. Okay, meaning, which isn't that hard, right? So if I want to do this by hand, I would add up all the frequencies. Oh man, that's annoying. Right, 20 plus 22 plus 23 plus 34 is 57, 79, 99. Right, so they sum to 99. So if it wants the probability for each one, I just do 20 over 99, 22 over 99, 23 over 99, 34 over 99, and that will give us these, okay? Now, my advice would be, once you have that, come back into Statcrunch, enter each one. So I'd enter 0.202, 0.2222, oop, 0.2323, 0.3434, and then I'm going to do the same exact calculation if it asks me for the mean and standard deviation. So I'll go stat, calculators, custom. My values are games played. My weights are in var4 now, and then I compute. It gives me the graph, so you can see it's. Ooh, let's see which one it is. Well, either way, it gave me the mean, it gave me the standard deviation. So when it asked me for that, that's great. I just have to line it up. Well, we can see that the highest one, if we use some analysis, the highest one goes up to about 0.35. So 1, 2, 3. So this is not halfway, this is halfway. Just 0.25. So it's not C, right? That only goes up to 0.25. These go up 1.123. It's not B, right? Because this This has three that are above 0.3, so it's not B. Um, it doesn't look like it's A either, so I would go with D here, okay? So this gave using that calculator gave me the graph as well as the mean and standard deviation. Going on, question 10. Why is it not clearing that? Okay. So same thing, right? As long as I have some data that I can use in Statcrunch, which I have here, what I can do now, this is a little more annoying, so bear with me here. I gotta open this up and get done. I gotta open this up to get the relative frequencies. If you follow this, the only way to do it using Statcrunch is the most ridiculous way. We have to do graph, bar plot with summary. We have to make sure it puts the value above the bar. My categories are X, my counts are frequency. I hit compute, and then you can see, oh, I have to change it to relative frequency. See, that's what I get for rushing. Change it to that. Now, oh, I can't see, so I just move this, and then boom, they appear. And you can see these are all the answers I got. And then I could re-enter this data back into Statcrunch so that when it asks me for the mean, which it will, right? So I enter this all back in, 0.011, 0.03, whoop, hit enter, 0.573, enter, 0.277, enter, 0.081, enter, 0.019, enter, 0.004. Then I just do the same thing I was doing before. I do stat, calculators, custom, select my values as number of children, my weights or the new column I created, and then I will get the mean and the standard deviation, and I can complete the problem, okay? So that's a really, we've used it for almost every question here, so that's a really good tool for these. Okay, and then we come to a crazy question. Now, it's probably good to know how to do this by hand, but I created my own way to do this. So I'm going to show you guys Statcrunch how to do it. And let me close this. We open Statcrunch. Now, this is a very technical problem, and I'm more familiar having done these from other math courses. So it's expected value is important, but I don't think it's going to be something I'm going to focus on the test because it's more a math topic. Okay, so the whole idea is how insurance works is they are just expecting bad things not to happen, right? They have probability things calculated, so they kind of know what to expect. So if all these crazy things happen, that would be very extreme, and they just don't happen. They don't happen. So they charge a female $210 per year for life insurance. God forbid she dies, they would have to pay her out 210,000. Okay. So we're doing this from the perspective of the insurance company. So it'd be negative 210,000, except she paid us at least 210. So we got something, right? So that would be 209 790, right? In other words, if you add 210 to that, you get 210,000 back. Now, the probability of that happening is 1 minus this. So we want to do 1 minus 0.999544, which would be, hold on, 0.000456. Okay, so the probability of her dying is the opposite of her not dying. So we'll enter the other one right there. 999,544. And the payout to the insurance company for this is all for one person basically, is they get 210. So look at it this way. The probability of this woman not dying or living is 999,544. So very high. The insurance company makes $210 in that case. In the unlikely event that this person dies, they lose a lot of money. But if you sell this to a lot of people who aren't dying, the insurance company is winning. So it's sort of a law of averages. We want to know how much is who's winning here? Is the insurance company winning or the people's families of the lost loved one winning? We can actually, believe it or not, calculate the same exact way we just did. Stat calculators custom. Our values are the dollar amounts and our weights are the probabilities. We hit compute. The mean is the expected value. Okay, so this would be 114. Okay. And then the standard deviation is calculated as 4483. All right. The reason I want you guys to pay attention to that, the way we just did is because the next question is going to ask you to find standard deviation. I don't feel like calculating it again. Okay. So this one is just doing the same exact setup like we did here, but it's asking you to calculate standard deviation. Okay, moving on. Um, Sort of another type of problem where you can create the payout formula. So a player can place a $5 bet on the number 10 and have a 1/38th probability of winning. So we'd want to know what's 1 divided by 38. That's going to go in this column. So what's 1 divided by 38? Oop, 0.0263, let's say 0.0263. Okay, so that's the probability of winning. So what's the probability of not winning? 1 minus that, so 0.0 or 0.9737. Okay. Now, what's the payout? What's the payout if the person wins? They put a $5 bet and and they if they win, they get 175. So the player gets to keep the 5 they paid plus 175. Okay. So in that case, they don't really win back their 5. They just don't lose that 5. So they end up positive 175. If they don't win, which they probably won't, then they lose $5. So you might be like, oh, this makes sense. Well, let's see. Let's calculate the expected value, and that's going to be the mean. So just go stat custom variable. One's the payout, the weights or the probabilities, which are in column 2. And you can see the mean is the expected value, meaning every time you play this game, just like gambling, you're expected to lose 26.6 cents. Okay, and it gives us the standard deviation. So for this problem, if you're expected to lose 26 cents every time you play, you multiply that by 1,000. So the person's expected value is negative $266 for that one. Okay. So again, you guys have help with these, so it's not like you're on your own, but that's how all these problems are done. So open up this one in Statcrunch. It's the same thing. This is some sort of grand prize game. I don't know what the game is, but if you win, you get $15 million. That's not bad. Okay, 15 mil, we'd all be driving Lamborghinis, wouldn't we? We'd be like, let's see, 15, 1, 2, 3, 1, 2, 3. Is that 15? Oh, that's 15 million. Okay, ready? I already calculated the expected prize, but it's the same thing. Stat, calculator, custom. The values are the payouts. So the X, then the weights are the probability. And this mean is the expected value. So 30 cents. So this is a game where you're going to win something every time you play. Okay. So, all right. So that's that one. Let's see. Okay, this one, again, this is sort of a blast of the past. We have to do our own frequency calculation first. So we have to find the mean from raw data. So what we're going to do is we're just going to use stat, summary stats columns, means already included. So just like that. And then boom, you get your mean is 3.1. Okay. And then the rest I'll leave to you. But just be aware you're going to want to use Statcrunch for this problem. So anything we've done could be in play. This is basically blast back to chapter 5 stuff where we did correlation. Open the data in the table. Okay, the first questions is asking, what's the response versus explanatory variable. We do, well, we'd want to do a dot plot or a scatter plot. So graph, scatter plot, X variable is square footage, asking price is that, and then just match this with the right thing. Now it's asking us for R. Do you remember how to do that? Is this correlated, right? Is there a connection? We do stat, regression, simple linear, X variable is square footage, Y variable is asking price, compute, and then we get our R value right here, 0.922. So not only should you know how to calculate that, but you should know what that answer means. That tells us there's strong correlation between square footage of a home and the asking price, meaning how much you asked the house to be bought for. 17. Frequency calculator. This is just to refresh you on how we did this in Statcrunch. Obviously, we could just do it by hand, right? That's how you're going to do it on the final. It's not that hard, right? How many times do you see ones? 1, 2, 3, 4, 5, 6, 7, and count them up. But we're kind of lazy as humans, so we want calculator to do it. Do stat, tables, frequency, select the column, calculate, and the frequencies are right there. Okay. Also gives us relative frequency. Just know that if it asks for probability, we just use the relative frequencies. Okay. If it asks for mean, that's a different story. Okay. Question 18. We're almost done, guys, but this is a lot of refresher. And I want to show you exactly how to do these without any mistakes because it's easy to get lost and think, oh, this is so hard. So there's one quick trick that will help us with this. And we did this in the previous section. So the way to do this with Statcrunch is we actually have to manually enter the midpoints of each interval into a new column. So what's the midpoint between 10 and 20? 15. Midpoint between 20 or 30 is 25. The next one's 35, 45, and 55. Then to calculate the mean here, we can do exactly what we've been doing. Stat, calculators, custom, select values as, this is where I got a little thrown off. Which one is the values? Which one's the weights? Well, the weights are going to be the, what did I do? Weights should be it should be number of students, yeah. And then the values should be the midpoints. Let's try this. And yep, that gives you the answer. The mean cost is 33.89. Okay. Moving on here. Discrete random variable is just definition question means. This is what we've done a million times, guys. So open it in Statcrunch. By the way, calculating this isn't too hard. It's just much easier to use Statcrunch. So by hand, you just multiply this times this, this times this, this times this, this times this, and then add it up and divide by the total number of things. But using Statcrunch, do stat, calculators, custom, the values is X, the weights it's P of X, and then hit compute, and you get your mean. Okay, that's mu. Mu is the mean, sample mean. And let's see, one more. We have to do a probability distribution. So what we'd want to do is, we could do this by hand, right? We could add these up, divide each one by the total, enter in a Statcrunch. We could also do this if you want to be clever. Open the data in Statcrunch. Sorry, I always have to think about this because this is the least intuitive way to do this in the world. So this is the one where we have to do graph, bar plot with summary, and then we add that we want to do a relative frequency calculation, categories as stars, counts as frequency, compute, make sure it displays the value. And then boom, you have your relative frequencies. But if you recall, these are the same as probabilities. And that's how you do this one. All right, that's it for 6.1. Keep working hard, guys, and more to come.